an assignment on arrays. If you haven't gotten it done, go ahead, please turn it in. Yeah, whatever. So pound sign include, IO stream. You don't necessarily have to type along with this. If you want to, that's totally cool. Pound sign include string. Using namespace, std, int main, system pause, all of our good old boilerplate. That's about enough. Okay, so we're going to declare an array of ints. Somebody remind me the syntax. The name of the variable will be called ages. So, and it's an array of ints. So what will the syntax be? What's the data type? Int. And then we said that the name of the variable was ages. And then what's next?
How many spaces do we want?
Yeah, we have to declare how many spaces we want, which is best served by making it a constant. I'm just going to call it num ages. Alrighty. Now we're going to write a loop that will run through the number of ages, printing them all out as a list. And we're going to make that a function. Doesn't have to return anything, so I'm just going to call it void. And it's going to be called print ages. Make it all lowercase, just to make it easy. And it's going to take an integer array, which I'm just going to call IA. I could call it ages, but this will print out any kind of array. I guess if I called it ages here, I could call it ages here. I think I'll do that just for simplicity's sake. And we're going to pass in the length of the array. If constant was defined as a pound sign, as a pound define up here up at the top, then we could assume that it was available for all the functions in this project. But it's not, so we're going to pass that in. And we're going to use a for loop. For int x is equal to 0, x is just our counter. X is less than length, x plus plus. This is all separated by semicolons. And we're going to see out that number, x, followed by a tab, which is \t. Backslash is the one over the enter key. Followed by the number in that array at that position. Followed by an ENDL. And that's enough. So down here, when we call it, we will call it like this. Print ages. We will pass in the name of the array, and we will pass in the length of the array. And it will print out 10 different ages. Might even work. Let's give it a shot. Now right now it doesn't have any data in it. We'll probably see random garbage in our array. Yep, random garbage. What could we do to zero out the array?
Set values equal to 0.
Yeah, we could run through the entire array, setting them all equal to 0. It's possible that we could also use an initializer list. Let's try the initializer list first because that is a much shorter syntax. Let's see if that will compile. Okay, so that's a shortcut way of zeroing it all out. If that didn't work, we'd have to use a for loop that looked just like this one that zeroed it out. Here's what that would look like. Then I'm going to erase it, but here's what it would look like. We would count from x to the length of the array, which is 10, which is num ages, and we would set the ages array at that specific position, x, equal to 0. You know, it doesn't take that much longer, you know, to type that, but it's nice to be able to do it like that. Either one would work. Alrighty, now let's write a little loop that will let these values be changed one by one. And what I mean by that is we'll ask which position we're going to change, and then we'll ask for the value. So that sounds like a good thing to put in a while loop. I'm just going to make this a while true loop, and then if they enter a -1 as the index, I'm going to use a break statement to get out. It's the easiest way of doing these things that I can think of. So let's make a variable called choice, a variable called item. Actually, choice is going to be item. And one called value. And let's tell them we want to know what their choice is. Change which item, or -1 to exit. Let's read that in. And if choice is equal to -1, or if it's less than 0, we will break. What does break do? It doesn't exit the whole function, but it certainly exits the while loop. It'll run down here, and then it'll execute this pause statement. All right, now that we've asked that, let's ask for a value. Cout, what is the value for item number choice? And we'll read that one in as well. And then we're going to change the value of the array at that element. So ages at that choice is now equal to the value that we've typed in. Might even work. Let's run it and see. All right. We have items 0 through 9. Change for which item? Firstly, let's try out that clause, -1. Okay, quit. Do that again. Let's change element number 5. Now 5 is now equal to 100, but I forgot to call the print arrays function, so we're not getting to see that. So why don't we call print ages every loop? After we've changed it, we'll print out the array again. So after the call to ages print brace choice, we'll call print ages again. All right, change 5 to the value 100. There we go. 5 got changed to 100. 9 got changed to 200. 4 is equal to 300. I don't know what these ages are measured in. Okay, so we have written a little routine which would run through and print the ages. What if this thing needed to calculate some kind of error? Let's come up with a better one. Let's make one called average ages. This one is going to return a value. I'm going to put this down here, but eventually we'll have to declare a prototype for it up at the top. Average age. Again, we're going to pass in the array events and the length of the array, so we know when to stop. we know how to calculate an average. You have to have a tally variable or a sum variable that starts at 0, and then you iterate through the loop. This kind of iteration should get to be old hat pretty soon. I should have been making, I'll type this in, come to think of it. X is equal to 0, X is going to be less than what? In order to iterate through the array. Yep, I hear one person say it. Anybody? Do I have a second?
What did you set it to 10?
Well, I could set it to 10, but length. Yeah, X is less than length. X plus plus. And then tally plus equals ages at that specific value. And now we're going to calculate the sum, or excuse me, the average. Float average is equal to tally divided by the length of the array. And we're going to return that value. So I hope this makes sense, especially that right there. Really want you to know how, in 3 lines of code, to write a loop that will sum up all the values in an array. So I'll just put know this, and I'll put it in our notes. Okay, so in order to get this to work, I'm going to have to put a prototype up above that has this defined in it. So I need to scroll up above main and paste a prototype for that function. Then I can call it. Now I can get the average out. Float A, or AVG, is equal to average age. Pass in the ages array, pass in the length. And I can print that out as well. Average age equals, followed by the average. So let's see if that works. First time through, the average ought to be 0. And if you were trying to type along, I should probably leave this on the screen a little longer. Okay, so right now, there's no data. So if we say set item 0 to 0, the average is 0. Everything is still 0. Now let's change item 0 to a 10. Okay, now the average age is a little bit smaller. It's 10 divided by 10, so it's got an average age of 1. Let's change item 1 to a 20. Now the total is 30, so the average age is 3. Let's change item 2 to a 77.5, just to get it off the even numbers. Well, that's not what I was expecting. What did I do wrong?
Because we don't know what the float.
Yeah, it's an array of ints, and I typed a float into it. My mistake. Please stop. Okay. So I should have made it an array of floats after all, but I'm not going to go back and change that. Okay, let's do that again. Item 1 is a 1. Item 2 is a 77, which gives us an average age of 7.8. That's working. What if we needed some kind of error handling in this? Like, what if the code was supposed to tell us if there was an age of -1? Or an age below 0. If any of the ages are below 0, it's an error condition. And so you could do that inside the float function here. You could say if ages parentheses x is less than 0, then cout error age cannot be less than 0. But it's really not the only thing we want to do. Alrighty, so if I say item 1 is a -1, while it's calculating the average, it says average age is negative something, but it prints out the error message as well. This code up here does not have any idea that an error occurred. We call average age, it returns the value. We don't know whether it's an invalid average or not. If there's a negative number in our array, it's an error. But this code right here does not know that. And somebody had an interesting way of doing error handling in their code. if you're here, go ahead and remind me what you did. I don't know if you remember what I'm talking about, but in one of your programs, you had a variable which you set equal to something if there was an error condition. Do you remember how you did that? Nobody's going to fess up. All right, here's how you could do it. What if you declared a global variable up here? Bool, error equal false. And then down here, if you get into the error state, you set that equal to true. So you could check right here, after you call the average function, if error, then you don't do something. You don't print out the average. Else you do print out the average. This is one way of handling it, but it's not necessarily the best way. So if there is an error, if the error flag is set, we're going to print could not calculate average. That's enough of an error message. Okay, so if you look again, we have an error here. Excuse me, we have a variable called error. It's set to false. But when we call the average age function, if one of the ages is less than 0, then that variable is set to true. This is called a global flag. It's an error indicator. It's a global variable. A global variable is one that's defined outside of any of the functions, outside of main or anything else. And that way, both main and this average function have the ability to check, to either set that or to get the value of it. So now to work. There's still another problem with it, but this is going to work. Okay, 1 is going to be 100, but unfortunately 2 is going to be -1. Now that's an error. It says error, age cannot be less than 0, could not calculate average. So instead of displaying an inaccurate average, it's showing the error message. I hope that makes sense. I'm not going to give you any code which relies on that, but that is certainly, it's got a very important part in it. The important part is that this variable, since it's declared as global, it's not local to any specific function, can be shared by multiple functions. And so it's being used as an error indicator in this case. Well, it's not really a good way of handling it. What if, I'm not going to even spin a what if. I'm just going to say that it's not the best way of handling this kind of thing. But why are we resorting to that? Is there any other way that we could let the calling code know that average age suffered an error? Well, we can't return a false because we're already supposed to be returning the average. So we're kind of up against a brick wall. What's the brick wall? Which is that a function can only return one value. And it'd be nice to return both the average and an error state. There is a way we can do that, but we can't return two values. It'd be really cool if we could do this, but Python's the only language I've ever seen that lets you return two things. So we can't do that, but we can pass in a variable that can change. When you declare parameters like this, these are known as pass by copy or pass by value, meaning that even if you try to change the length inside this code, it's not changed back out here. And we could prove that. Down here, before I return the average, I could say length is equal to -100, which is a totally inaccurate value. And then up here, after I call average age, if I try to print out num ages, it's still going to print out 10. It's not going to print out -100. It printed out 10. So let's look at that again. Maybe I need to rewrite this example because it's getting a little bit too big. I'm having to scroll up and down. I'm going to take out some of these braces. Get it all to fit on one page. There we go. Okay, now, and I'm going to move this. Well, I really have to leave that there. Anyways, you see that we're setting this variable, this parameter that's being passed in. to negative 100, but by the time we get out of here, num ages is still the same. In fact, they couldn't change num ages. Why? Because num ages is a constant. Nothing can change it. So, what's going on there? Why isn't it able to change the value that's being passed in? You know, if I'm passing in 10 here and then I set it equal to 100 or negative 100, when I get out, you'd expect that to be changed. Or maybe you wouldn't expect it, and that's correct. This is known as pass by copy. C++ by default does pass by copy or pass by value. And what that means is that average age is a function and it gets copies of the original data. It's like you're my function, and so I go over here and I write down a value on a piece of paper and I hand it to you, and I write down another piece of paper and I hand it to you. You have copies of that data. You don't have the original data. You can do anything you want to it. You can set it equal to negative 100, you can zero it out, whatever. It doesn't bother me up here because you only got copies of these values. That's why these variable names can differ. Here I called it ages and num ages. Here I called it ages and length. This name did not have to match this name because they're not the same thing. This is just a place that gets a copy of that value. And this is just a place that gets a copy of that value. We could call this one Fred and we could call this one Barney. And as long as that was correct through the rest of the code down here, that would work just fine. It doesn't matter that that one doesn't match that one. That is known as pass by copy. But there's another way you can pass data in. There's actually two more in C++. There's pass by copy. Let me write it down over here. That's what we're seeing by default. Pass by copy. There's also, yeah, like you can see that, pass by reference. Pass by reference means that you are actually passing in a reference to the original variable, meaning that if your function changes it, it's actually changed. So let's demo that. I'm going to revise some of this code. I'm going to call this one main2 so that I can start writing some new functions. Okay, so up here in main, I'm going to declare a variable called a, not a big deal. And then I'm going to write a function called change a. Change a. And I tell you what, I would like for y'all to type this stuff in. We're not going to make this overly complicated, so it's not going to be too much typing.
Can we delete the rest of the stuff, or is this still going to be?
This is brand new. You don't have to delete the rest of the stuff, but call your main down there main2 so that you can write a new main. Okay, so the change a function is going to set a equal to 100. Whoops, my mistake. There we go. So here's what I want change a to look like. Yeah.
I'm not able to run my programs. I'm not able to start programs. I just tried running that test one because some other ones weren't working, so I restarted the computer.
And we expect computers to do the same thing every time. So this should be working. Of course it's not. View the solution. Rebuild the solution. You're gonna fail or you're gonna work? Succeeded. Now run please. Oh, you booger. Well, I'm glad it's working. I don't know why we had to clean it and rebuild it.
Okay.
Just kind of like when you do tech support, anytime somebody calls in with a problem, you say, have you tried turning it off? Well, in this case, have you cleaned and rebuilt the project? Okay, so here I go. I'm going to call change a right here, and I'm going to pass in that a variable, and then I'm going to print it out. Cout a equals a, end of line. What do we expect it to print out? When the program is done, oh, I need to stick that pause in there. System pause. What is this line going to print out? Yeah, it's going to print out 0. If anybody was going to say 100, it's totally understandable that you would say 100 because that's what it seems like it should do. But it doesn't, because this is passed by copy. This is passed by value. This variable is a copy of this variable. And so changing it doesn't make a difference to this variable. Let's run it to make sure. There are build errors. Well, main2 must return a value. Okay, fine. Really? It wasn't doing that earlier. Return 0. I had to go add a return 0 to my old main in order to get this to work. Alright, a equals 0. That's what I predicted, and that's what it did. But now we're going to rewrite it so that this function actually can change the value. But first, I don't want to go too far because I just told you I'll start typing this. And then I'll have to- I'm going. Why is that? No, it's completely not that good. Congratulations, you found that problem in yours. There's probably another error that we don't see yet, so that's stuff on top. What is the top error? That's another identifier. It's weird that it was giving us that error message. The problem didn't have anything to do with it. Okay. So we're typing this in. Get a start. Got yours going? Yeah. It's printing our big mighty 0. All right. And yours? Yeah. Y'all got it going over here? Alrighty. To get this to work, we would want to tell it to pass it by reference. There's a little symbol. In the C# language, it's really easy. You do that. Yeah. That doesn't work in this language. We have to be more cryptic. This is C++. You put an ampersand in front of the variable. And that says, oh, this is not just a copy of the variable, it's actually the variable. So when we pass in A here, it's not passing in a copy of A, it's actually giving it the variable. And if it changes the variable, that's what happens. When it comes back, now A is going to equal 100. There it says A is equal to 100. So that's passed by reference. Tell you what I'm going to do. I don't know how to put this in the notes so that it'll be completely obvious. Doesn't change it. That's that comment. And then we're going to write another version of change A. That does change it. And I'm going to call it change A2, or change A ref. in order to indicate that we're actually changing the reference. So the ampersand means reference. Get a reference to that variable. This thing is actually holding the variable. This has just got a copy of it because it's passed by copy. This is passed by reference. So if we call change A, it doesn't change it. But then if we call change A ref, it does. So change A ref, we pass in A, and then we print it out again. And that's what we get. After the first call, it's still equal to 0 because it was unable to change it. It just had a copy of it. The second call was actually able to change it because it called this function and it was passed in. There are times when passing in something by reference is much faster than passing in a copy. Particularly if what you're passing in is larger than an int. What if it's some kind of data that's 10 megabytes long? You don't want to copy that value, 10 megabytes, in every time you enter that function. You don't want it eating up another 10 megabytes of your computer's memory. So there may be speed considerations when you want to pass by reference. If it's a small data structure, it doesn't really matter. If it's only 4 or 8 bytes or something like that, it doesn't take that long to copy 4 or 8 bytes, the size of an int or a double or whatever. But if it's a large data structure, then you can get some speed savings by passing in by reference. But what's the risk? The risk is that this function can change the value. So generally, you only want to do this if you actually want your function to be able to change it. So using this idea, we could go back to our average function and pass in something that if it got set to true, we knew that there was an error or a success. So instead of having some global variable which indicated the success or the failure of a function call, we could instead pass a variable in, and if it got set to true, it could mean that it changed it successfully. And if it got set to false, then it could mean that it didn't change successfully. So I'm going to rewrite that average function to incorporate this idea, but I'm not going to actually implement it. That's dumb. I got 2 sets of code in here, and I don't want to keep swapping between them. I'll show you what it would look like anyways. Down here below main, I'm going to go ahead and do this. Let's see. Who needs a copy of this part of the code right here because you didn't get it up and running? Okay, let me print that out for you. So if I wanted to rewrite that average function, here's one way I might do it. I'm going to just find it and change it. And I'm not going to actually test it, but I'll show it to you. Down here inside average age, why don't we pass in the result as a reference variable?
Is this something we should type into?
Nah. If I want y'all to, as we go along, I'm going to make a simpler example. Okay, so here, if we get into an error state, we're going to return a false. That means this did not work. And for that to work, we have to change the data type of this function to bool. If the function returns a true, it means that we did get a valid average. If the function returns false, it means we did not get a valid average. And then if we do get a valid average, then we will set the result equal to the average that we calculated, which had better be a float because we're actually calculating that. So you see what we're doing? We're passing in a new variable that will hold the result of our average function. And it returns a true-false value. If it's true, then the average function worked, and we should get the value out of result. If it didn't work, then it failed, and we don't want to use it. So in our code where we want to use that, it would look something like this. Bool is okay is equal to average age. Let me just comment this out because it's going to be a bunch of errors anyways. Okay, it would look like this. Bool is okay is equal to average age. We would need to pass in a result variable and then our ages array and then the length of the ages. Then we would check if is okay, cout, come on, the average is followed by the result. Else, we would print out an error message. I hope that makes sense. Let's look at it one more time. Here's our average function. It takes 3 parameters. One parameter being the array, one being the length of the array, so we know when to stop, and one parameter which will contain the result, allow the result to be passed back. In order to support the pass back, it has to be defined as a reference. And we return an error code. If it's true, then it worked. If it returns a false, then we know that the average is no good. And so we go through, we calculate an error. If we hit an error state, we return false. Otherwise, once we get down to the bottom, we set this variable that we passed in, the reference variable, equal to the value that we want to pass back, the average that we've calculated, and then we return true. So when we invoke it, we do it like this. We store the result of that function in a Boolean variable, a flag, so that we can check it. And what we're passing in is a result variable, which had better be a float, an ages array, and the length of the ages. Then if it's okay, if it returned a true, then we can use that value that we got back from it that was stored in the result variable. Else we print out an error message. This is a much better way of doing error handling than using a global variable. I say that, but then there are problems with this idea as well, which is that some languages do not support passing by reference. But in C++, it's a very, 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 very common thing to do. So if we hit PowerPoint 6, we will learn more about passing by references. Of course, I haven't downloaded 6. I've downloaded every other one except 6. guess to sum up, if we were going to type some notes, C++ by default, the parameters are pass by value, also known as pass by copy. The parameter gets a copy of the value of the argument passed in. Even if the function tries to change that parameter, that does not affect the variable or the value that was passed in. And remember my example, it's like I wrote something on a piece of paper and then I hand it to you. Doesn't matter what you do with it. I still have my original. I just made a photocopy of it to give to you. You can also set a parameter to be a reference parameter by using the and sign. So let's make two functions. One called doesn't change, which takes a variable called a and tries to set it equal to 100. And then one called change, which takes a reference so that it can change it. So even though this gets set to 100 inside here, by the time it returns back, whatever we passed in is not changed. So if we have main down here, and we do this, x is equal to doesn't change, and we pass, whoops, x is equal to 0, doesn't change, and we pass in x as our variable, and then we print out x, it's still going to print out 0. Now that's just all a recap of what we've already did. And then if we call change x and print it out again, it's going to equal 100. I don't know why I said 0 there. Print out x. Okay. So this prints out 0 because it was not passed in by reference. This prints out 100 because it was passed in by reference. If it's being passed in by reference, it better be something that you could change. If we typed in a number 12 there, there's no way this code could set that equal to 100, right? I mean, that's hard-coded. It's like it's burned into metal. It can't come back and be changed. So this would give us an error. We could prove that in our source code by coming back here, and where I had change by reference, if I change that to a number, like 10, right there, it underlines that. Because there's no way that it could change that. It's a constant. It's a literal. There's no way it could be changed. You have to pass in a variable in order for it to be a reference. These must be the old notes. Okay. All right. You can use this to allow a function to pass back a value without using a return. Or you can use a return for something else. You can use return to return an error code. Or you could pass in a reference, which you would use as your error code indicator. It would work either way. So functions. We've been using functions. Let's talk about them. Modular programming is the breaking up of a program into smaller, manageable functions. So a function is a block of code. It's a collection of statements that perform a task. Why do you make functions? You improve the maintainability of programs, and it simplifies the process of writing programs. So, for example, now that we've written a function that averages out an array and returns that average, we could use that code over and over and over, rather than have to write that for loop each and every time we wanted to calculate the average of an array. So you write a function once, and then hopefully you get to use it over and over and over. Defining and calling functions. We know how to do this. A function call is when you execute that function. And a function definition are the statements that make up the function. So that is our function call. These 4 lines is our function definition. So a function definition, you have to have a return type. If it's void, it just means it doesn't return anything, but you still have to say void. Name, it's got to have a function name. Parameter list, if it's got any parameters that it accepts, they will be between the parentheses. And then it's got a body of the function. The body of the function is the stuff that's enclosed within the curly braces. Like this. Main. Main being the function that we type each and every time. It's supposed to return an int. It doesn't accept any parameters. You can make it accept parameters, but this one doesn't. And then it's got a function body, which is everything between the curly braces. If a function returns a value, that type has to be indicated in the function definition. So if we have a return 0 at the end of it, then it's going to have to be int main. If you have return false at the end of it, then it better be bool whatever. So its return type has to match what you're actually going to return. And if it's not going to return anything, you declare it as void. So when you call a function, you give it the name of the function, you use the parentheses, and then any parameters that are required, you pass in between the parentheses. So your main function can call any number of functions. Functions can call other functions. Functions can even call themselves. That's called recursive programming. The compiler has to know what that function looked like, though. And that's what we use the prototypes for. The compiler has to know the name of the function, what its return type is, the number of parameters, and the data type of each parameter. If it doesn't know that, then it can't compile correctly. So if you're putting the body of the code after the place where it's being called, like you put your functions below main, you have to use the prototypes. Where's the best place to put prototypes? In a header file. Function prototypes, we've talked about this. The function prototype is a function declaration without a body. You place your prototypes near the top of a program or in a header file. The program must include either the prototype or the full function before any call to that function, otherwise you get a compiler error. When using prototypes, you can place function definitions in any order in the source file. So if you define your functions up at the top, then you don't have to worry about whether you have actually put the body of that function in the place where it needs to be called or not. Sending data to a function. The things between the parentheses are known as arguments when you're passing them in. So when we say take A and raise it to the power of B, A is an argument and B is an argument. Why were we also calling them parameters? Well, because when you're inside the function, they're called parameters. So if we go back to our sample, this A is a parameter. This X is an argument. The argument fills in the value of the parameter. Now those terms get mixed up and get used interchangeably, but technically that's the definition. Between the parentheses up here, it's a parameter. Between the parentheses down here, when you invoke it, it's called an argument. So here, num is a parameter, which would accept any integer value passed to that function. It could be a constant, it could be a literal, whatever. As long as it's an integer or something that can be easily converted into an integer, you're good. So a parameter can also be called a formal parameter or a formal argument. An argument could be called an actual parameter or an actual argument. Well, why don't we just throw in more terminology to confuse ourselves? So I'm skipping that slide. So for each function argument, the prototype must include the data type. This is a prototype for a function called even or odd. In the function itself, you have to define the name of the parameter. But in the prototype, you don't have to. You can just give it the data type. So in this code over here in my C++ program, I defined one prototype. Don't know where it is now. Here it is. I didn't necessarily have to give it variable names here. It would still compile even if I made it look like that. Is there any advantage or disadvantage to making it look like that? It still works. But I don't particularly like that. Y'all have any strong opinions about it? Why could that be better or be worse? If you were writing this code and trying to understand it, and you looked up and you saw that prototype that said int, comma, int.
I think it's more confusing. You don't know what you're talking about.
Right, you don't even know what those variables are supposed to be. What is int? I don't know. Oh, and since it was supposed to be an array, actually I would have to define it like that. But still, we don't know that that's a length. We don't know what kind of data is supposed to be in that array, what it represents. So I like leaving the variable names in my prototype, but you don't have to. So, function calls. The value of an argument is copied into a parameter. That's why it's called pass by copy or pass by value. A function can have multiple parameters. You just separate them by commas. Here we go. Here's a function that has 3 parameters, num1, num2, num3. So when you call it, you had better send in 3 integers in a row separated by commas as its arguments. Passing data by value, that's what we've been doing. Pass by value is when an argument is passed to a function, its value is copied. Changes to the parameter in the function do not affect the value of the argument. Using functions, yeah. Okay. The return statement. We know what a return statement does. The return statement causes that function to stop processing and execution is returned back to the calling program. And you can stick it anywhere inside that function. It doesn't have to be the last statement in the function. You can use more than one return statement. I'm going to write a dumb-looking function here. Void dumb function. And it's going to accept an array of ages, and it's going to accept a length. And it's going to pass back. It's going to do different things. Instead of making a void, let's make it an int. Okay, so firstly, if length is equal to 0, then it's going to return a 0. Then second, if length is greater than 10, it's going to return a 10. Else it's going to return ages at element 1. Totally stupid, but it works. I mean, it doesn't do anything useful. But if this parameter, this argument is 0, it returns here, back to the calling code. Else it keeps processing. If length is greater than 10, then it returns a 10. We're out of that function and back into the calling code. Else, the last thing is it returns the second value in the array. Why do I call it the second value when that says 1? Because what's the first value's number? 0. Yep. So your function can have as many return statements as you want, as you need. However, one programming paradigm is there should only be one way out of a function. There should only be one return statement. But if it makes the code easier to read, go ahead and use more than one. So a common way of writing these things is that if there's an error up at the top, you put a return. You get out of the function as fast as possible. Then you go ahead and do the processing. And then you have your valid return statement at the bottom. That is one very common programming paradigm. You handle your errors up at the top. If there is an error, you return early from the function. Otherwise, the rest of the program, the rest of the function is devoted to actually doing what the code is supposed to do. Our average function that we wrote here had 2 return statements. One was inside a for loop. If it found a bad value, it returned to false. Otherwise, it returned to true. It's another example. If there is no return statement, then it returns automatically when it hits the last closing brace of the function. But that only works if it's declared as void. Returning a value from a function. We know how to do that. You just type return, space, followed by the value, either a variable or a literal. You know, a literal is something like false or true or -1. A value is a variable. You know, return x, return sum, return average, that kind of thing. So the POW function, they wrote a function that takes this variable and it raises it to this variable and it returns a value. So you can be sure that if we go and look at the source code for the POW function, we would see. Let's go look at the source code for that function if we can find it. I'm going to # include CMath. This is just for fun. And then I'm going to use the POW function cout 3 to the power 5. And I want to see how they wrote POW. So I'm going to right click on that, highlight it, right click it, and do go to definition. That should show me where that function is defined. So what I did is I highlighted that code, I right clicked it, and I chose go to definition, and boom, here is what the POW function looks like. Well, it just calls another function. So I could go to that one's definition. And it's not even taking me anywhere. I'm not going to take any time trying to figure that out. But you can use that also to try to track your own functions down. For example, here I'm looking at a code that calls change a reference. That could even be in another file. What if I didn't know which file it was in? I could right click on it, do go to definition, and it would take me to that file that contained that function, and it would highlight that function. So down here, when I call print ages, I can double click on print ages, right click, do go to definition, and it'll take me to the print ages function. It's a fast way to maneuver around inside your program. So writing a sum function that takes two arguments and then returns their sum. So we declare two parameters, num1 and num2. We declare a result, we add 1 and we add 2, and we return that result. There's something hinky going on here. Why is this declared as a double if this is returned as an int? One of those should match the other. That should either say int there, or if it doesn't, then that should say double there, because your data type that you return should match the return type of the function. So we call it, we invoke it with sum parentheses 20 comma 40. 20 gets copied into that value, into that parameter. 40 gets copied into that parameter. And so it returns 20 plus 40, so 60 comes back out. So that if you are going to return a value, you actually have to have a valid data type that's not void. And the prototype and the definition have to say that. Once you get that return value, you should use it. You should either assign it to a variable to do something with it, or you could send it to cout, or you could use it as an expression in order to calculate something else. Returning a Boolean variable. I showed you how to do that. In our calculate average function, we returned a true if it was a good average. We returned false if it was invalid data. So a function can return a true or false. Why would you do that? If the function could not complete successfully, you may as well return a false out of it. You declare the return type in the function prototype as bool. And then the function body must contain one or more return statements that returns either a true or false. Here's their function, but not on this page. He's written a function called isEven that accepts a number. How do you see if a number is even? You modulus it by 2, and if the result is 0, you know it's even. So bool isEven. And then we declare a status variable that will contain a status. If the number modulus 2 is equal to 0, status is equal to true. That means that we're going to return a true there. else status is equal to false. Otherwise the number is odd. And then return status. So that's actually some cool code. I'm going to copy it into here. Bool is even. We're going to pass in a variable. If x modulus 2 is equal to 0, then we return true. Else we return false. Now his looked a little more complicated than that. He was storing the value before he returned it. That's one way of writing it. Or here's another way, is even to whatever. These are going to do the exact same thing, but one of them stores the value. So bool R for return value, or ret, or status is what he called it. If x%2 is equal to 0, that means it's even, and so we're going to set our variable status equal to true. Else status is equal to false, and then we return that. I don't know which of these you think is cooler. That's shorter, maybe easier to read. This one's easier to debug. Why do I say that? Because if you couldn't figure out what this function was doing, you could see out status right there. You could put some kind of debug message. Debug status equals, and then print that out. You couldn't do that here. There wouldn't be any way to hide, to embed a print statement inside this function so that you could print out its return value. That's really the only reason that it might be better to write it this way than that way. They both do the same thing. And so when you call it, it would look like this. If is even 10, we just pass in some variable. See out, the number is even. Else, see out, the number is odd. And in this case, it would in fact print that the number was even. Calling this one would be the same, because it does the same. Is even 2, but let's pass in an odd number. There we go. That would print that the number is odd, because it would come down here. Status is 11% equal to 0. No, so it's going to set status equal to false. It's going to return that value. We get that return value. We use it as our logical expression for our if statement. And if this is false, which is what it returned, then we will not do that. We will instead execute the else. Local and global variables. A global variable is one that you define outside of main. And I gave you an example of that. I gave you an error code. A local variable exists only while the function is executing. So in our code up here, this x right here is only valid from here to here. By the time we get out of there, by here, there is no more x. The scope of that variable is only from there to there. If we declared a variable here for some reason, a, then by the time we hit that closing brace right there, a is no longer valid. Just can't use it anywhere else because it's local to this function. X is local only to this for loop. We could not use that x anywhere else. You could declare another variable called x, but you can't get that data out anymore. And a, whatever a is equal to, we could only use that value a between the braces in which it's declared. So that's a local variable. A global variable is one that's declared outside of that function, or outside of any function. Int maximum expenditures, whatever, This is stupid, but there. This variable could be used inside any function. So if I wanted to print out max expenses down here inside of another function, I could do so. Boy, dummy. See out max expenses. That works, because max expenses is not just local to any function. It's global to every function after which it is defined. Couldn't use it up here. It's not defined before it gets to this point. So that kind of implies that you'd want to define your global variables up at the top. Now, global variables seem awesome once you get used to the idea, but just know that they're kind of frowned upon and that there are usually better ways of solving the problem than global variables. Just keep that in mind. But if it seems to fit, go ahead and use it, and then learn later the techniques to avoid them. So that's called the lifetime of a variable. The lifetime is just the braces in which that variable is defined. The lifetime of this variable, also known as the scope, is only between these two braces. The lifetime of the global variable is throughout the entire program, throughout that entire file. So a global variable is one that's defined outside all of the functions in a program. So the scope of that variable is a portion of the program starting where it is defined all the way to the end of the file. And it means that the global variable can be accessed from within the functions that come after the global variable is defined. You should avoid using global variables because they make programs difficult to debug. And any global that you create should be a constant. That's why that using a flag to indicate an error condition goes against the precepts of good programming that this author is instructing us. He doesn't say why, though. Maybe the text goes into more detail. I do not recall. So in order to make this valid code, I should actually make that a constant. I was kind of leaning that way anyways because I made all that uppercase. And anytime you see uppercases, you assume that it's a constant. So here's an example of global constants. He uses three constants: pay rate, base hours, and multiplier, which is the overtime multiplier. So that's the hourly pay rate. That's the maximum number of non-overtime hours. If you work more than 40 hours, you get some overtime. They're defined as constants. They're global variables that could be used inside of each and every function. Why would you be tempted to do that? Maybe you don't want to pass this data into every single function that you write that calculates, the pay rate. Maybe you don't want to have a function that requires you to pass that in as an argument, and that in as an argument, and that in as an argument. You might prefer just to be able to call the argument with one or no arguments, and have it calculated. And that's kind of what this is implying. Get base pay. All we have to do is pass in one number. I'm not sure what that number is. It's probably the hours worked. And then using these global constants, get base pay is going to return, it's going to calculate what the pay is, which would be the pay rate times the hours that was passed in. Same for get overtime pay. We're just passing in a value that is equal to the number of hours. And it uses these constants. So it makes these function calls shorter. We don't have to list 4 different arguments in order to calculate our get pay. We just have to use one. Now, do I think that's awesome? Not really, because what if these values change? I don't know. But it does illustrate that. So down here on the next page is a sample of code that actually uses these constants. Here we are in a function called, well, I don't even know where we are, but determine base pay. If hours worked is greater than base hours, the base pay is equal to that. Else, the base pay is equal to that. So it's using that constant in order to calculate something. And then later on, to determine overtime pay. If hours worked is greater than that constant, then it calculates overtime pay. That's about a good place to stop. Let's take a 10-minute break, be back by 8:50. That's a 12-minute break. Alright guys, what we're going to do next is look at file I/O, which is saving stuff to a file rather than just reading from a screen and printing it out to a screen. Because, you know, how often do you just display data and not save it, you know? If you were playing a game and it was a game that lasted more than a couple of minutes, you'd be really annoyed if you couldn't save the data to a file so that you could pick up the game and start playing it again. You know, if it's a role-playing game or whatever, if you didn't have a save point in your game, you'd be really annoyed. Well, a save point needs the ability to write the file out somewhere, either out to the network or onto a local storage or whatever. Also, reading from a file. You know, so when you open up a file in Word, in a word processing application, you go and you specify the file you want to read from. It reads the data in for that file so that it can display it on the screen. Then you make your changes to that file and you click Save, it writes it back out. So that's what we mean by file I/O. I/O stands for input and output. So go ahead and look, refresh your Dropbox and look in class 9. No, I lied. I don't want you to do that. Create a fresh solution. New project. So make a new solution and then add to it a new CPP file. And let's call this one source, give it your initials, and then file IO. Because it's sample file IO is what we're going to be doing. So, along with our normal boilerplate, we're going to be adding one more include, which is fstream. Fstream means file stream. So far, our streams have all involved in displaying to the screen and then typing from the keyboard. So we're going to do #include IO stream, just like normal. #include string, just like normal, but we're tacking a third one on. Include fstream. This gives us the ability to write out to a file or to read from a file. And we may as well use our namespace again. And I need to warn our Mac users that there's something weird. I don't know how to find the directory that your Mac program will read from. If we create a file and we want your Mac program to read from it, I don't know how to specify that.
On the hard disk.
Well, I know it's on the hard disk, but the path to it. You will probably have to specify a path to the file in order to get it to work on the Mac. So y'all will have to try a little bit harder than what we're going to be demonstrating in here. It's doable, and I can forward you some instructions on it. Just warning. Okay, so first thing we want to do is we're going to create an output file. Output file stream, OF stream. And I'm just going to call it out. Sometimes they use out file, whatever. Yeah, maybe I'll call it out file. And then I'm going to say outfile.open, and I'm going to give it a file name, something that's really easy to find on my computer. So I think I'm going to call it, I don't know, JGT output. Put your initials in it, followed by output.txt. Now we need to check to see if that file is open, because if it's not open, we need to just bail. Why might it not be open? Well, what if we specified a path that was invalid? Like, what if we wrote to the D drive and there was no D drive? Or what if we wrote to a file system that was locked and we couldn't open it? You know, it was a read-only disk, and here we are trying to write to it. So there could be errors. Here's how we check for the errors. If not out file, if exclamation mark meaning not out file, then we'll print out our error, cout could not open file. And it'd be nice to actually print the file name that we could not open, but I forgot to store it as a variable. And then return. I would like to change it so that this file name was actually in a variable so I could print it back out. So I'm going to need to make a couple of changes. I will wait until we're all done typing before I start recklessly changing what we've done so far. Okay, you see this thing here? Cut that out and put the file name and put it in its own variable called file name. So make a variable called string space file name and then set it equal to your file name like that. And then inside the .open call, then put file name. And more specifically for you Mac users, what happens is it builds your project and it runs it in some subdirectory that I'm not able to find. So even if you do a search for the file, I can't guarantee that you're going to be able to find it. Well, we'll find out real soon whether that's true or not. Okay. So if we get here and we cannot open a file, we print out a message, could not open file. Now let's also print out the file name. Cout file name followed by an end of line. And then let's return some kind of error code to the operating system, -1. We couldn't do it. But if all that did work, let's write something out to the file. So instead of doing cout, we're not going to do cout, we're going to use our file, out file. This is my favorite file, /n, out file, 1, 2, 3, /n. Now this isn't so great because I should put a pause in front of my return statement there. I'll fix that in a minute. I'm going to run it just to make sure it works, guys. Alright. It didn't display any output, but that's because we didn't send anything to cout. We don't even know that the program is done. So let's make a few other changes. For those of y'all who are using Windows, put a system pause up before the return -1 so that we get a chance to read that error message. And then above the final system pause, above the return 0, let's see out a program finished or just some kind of done message like that. That way we see something when we run the program. We don't see what it wrote though, but we can do a search for it. Since I gave it a unique file name, jgt_output.txt, it's possible I can go to the search window over here and type in jgt output and it'll start searching for it. It may never find it. I know where it's stored though. If I go into the Visual Studio directory, well, see, there it is. I typed it into the search box. It eventually found it. I double click and that's what it looks like. It says this is my favorite file 1, 2, 3. So it created a text file. And writing to the text file was as easy as sending output to cout. And the obverse is true too. If you declare something as an input file, reading from it is as easy as reading from CIN. Alright, so go ahead and run this and see if you can find your file. So this is program finished. Go to the search box, see if you can find CF output. Got yours, 50. There it is, awesome. There it is. While you're at it, go back to your search box, find your file again, but don't open it. Instead, right-click on it, and this is for your Windows users, and do Open File Location. It shows you where the file is. No, it doesn't.
Computer can't find it.
Okay, fine. Go out into your folder where your CPP file is stored, and you'll see it. So open up an Explorer window, go to wherever you create your programs. Mine is inside Documents, Visual Studio 2013, Projects. Project 3 is my most recent project. And they're inside the debug directory. Well, I'm not spotting it yet. Let me just search for it. Output. That didn't work. Let's go up a level. JGT output.txt.
There.
Really? Well, then where is it writing it to?
This is the project 3 folder.
That's what I was expecting. I didn't see it.
It's in the top folder.
Oh. Yeah, right there. Okay. So if you put your text file inside the same folder as the CPP file in Windows, it will be able to open it and read it. We could write another program that would read that data out. And let's go ahead and do that. I didn't finish walking around to make sure you can all find it though. There it is. Good deal. You found yours. Awesome. This looks like it's a completely different program. We need to move this file that you created into its own project. Or we need to just comment all this stuff out. What happened is you didn't create a new project, you used your old solution, and so now we have two sets of main in it. So let's just comment all this stuff out. Okay, cool. It's done. Go search for JGT out. Those were my initials. Okay, there we go. JGT out. .txt. Enter. Found it. So, were you able to find the file after you ran it? Got your done message, right? Right. So we need some way of specifying a path, so to like save it to your desktop or something like that.
Where would I?
The file name has to be more complicated than what it is right now. And I can't tell it to you right off the top of my head. I'll look it up in a minute.
What program could I write it in? Or what like icon could I write it in, save it as to where I can reopen it? Cause
Well, it's saving it somewhere in the bowels of the system. What was a suggestion for you? You, come here, let me show you what it's doing. And this is what I don't understand. He has run the program, which means it created a file. But if we come and we do a search for it, using Sherlock, it never shows us that file.
Can you pull it up? You didn't find any of your documents either, like the rest of this in? Where does your, you use Xcode, I'm assuming? So where does your normal projects go? It's depending on how you set it up. Oh, you open it that way, you move it.
I just put them in sweet test box.
So open your, where you keep all, go back to where you keep all the files, the documents. Your desktop. No, your iPhone for desktop.
If you click all files, does it show most recently edited files?
Did you add anything, does your stuff automatically save to your cloud? Because if it does, it's gonna save Google Space. And straight to your cloud, that way you got something that this is really
Thanks, not useful. Alrighty. Just a second, okay, second. Change your file name to something like that, that has a path embedded in it. So whatever your username is,
Which is exactly
right. So, just like it says up there, users backslash your Apple ID backslash desktop backslash and then that file name. Told you, it's gonna be weird.
We connected to an old server, just
And you were able to find it, it works for you. Oh, no,
Oh, this
that
is not
actually
mine.
this machine.
No, I have both because I had two. I have learned that this world does not run on both, so I have to run both.
Good, good choice. All right,
Open my
yes, sir.
iPhone, so it's
Semicolon at the end of that.
Oh.
And then, yeah, after the backslash. New line. Yeah. Oh, out file, take the space out,
On your iPhone.
take the space
It's
out.
all,
I have no idea, I'm not good at all this.
because if you back it up the way that your documents are there, then it's going to encrypt it in a way that you know.
I don't think that entire thing will work at your path. What is your username on this thing that you log in as? Like if you logged out and logged back in, what would it say your username was? need help? Gesticulate. We're all good? Okay. We're going to change this program so that instead of writing, well, instead of writing what we're writing, instead we're going to put some data in. Take this line out. This is my favorite line. Just comment that out. We don't want that data. But now let's write out some more data, like 100, 200, 300 on a second line. And outfile 400, 1000, 10. And then maybe one more line of data so that we have 4 lines of data in our program. 8, 9, and 7. Whatever these numbers are. It doesn't really matter what the numbers are. I just want 3 numbers per line. So now when I run it and I go find that file, the data in it is going to look different. And thank you very much, Teresa. I like being able to ask other knowledgeable students for help. Next semester, I'm going to ask if we can use the Mac lab for half of the class and then the PC lab for the other half of the class so everybody gets used to developing on more than one type of operating system. All right, then what we want to do is we want to make this program read that data now. So let's make a new function down here. Let's call it read. And it accepts a string as a file name. And then after our call to pause, we're going to read. So after system pause, do read, parentheses, file name. And then print another done message out. And then pause one more time. So here's what I added. We're going to have to add a prototype for this function, which we don't have yet. But after our last system pause, between system pause and return 0, we have now added these 3 lines. Okay, so now we're going to open the file and we're going to read from it, which is just as easy as reading from cout, except you have to set the file up first. You have to open it first. And instead of using OFStream, like we did up here, which stands for, whoops, my mistake. Where's the code? Instead of using OFStream like we did here, we're going to use IFStream, which stands for input file stream. So down here in read, do IFStream space in file. And then do infile.open. And pass in the file name. Now let's check to see if the file was successfully opened. If not in file, we're going to see out an error message. See out could not open file name for input, and then return a -1. Now that we have the file open, we can read from it, just like we could read from CIN. So let's declare 3 variables, int x1, x2, x3. Sorry. I'm spacing out on something. Okay. It's .eof. That's what I'm looking for. While, parentheses, not, exclamation mark, infile .eof, we want to read from the infile into x1, we want to read into the x2 variable, and we want to read into the x3 variable. And then let's print those out. Cout x1, x2, x3. That's not going to look real good because it won't have spaces between it, but it'll prove the point. It'll prove that we have those numbers. And then if all that worked, once we're done processing the file, we want to close the file and then we're going to return. So we're going to use infile.close like that after our loop, and then we're going to return. Alright, that's what our read function looks like. I had to zoom out a little bit to get it all on the screen at one time. Let's run it and see if it works. It's not going to work because I didn't define the prototype.
I have a problem on, maybe it's line 30, it's my read file.
Right, I did not declare a prototype for this. So take this line, well, just go up to the top above main and add this code to it. Int space read string file name semicolon. That should make it compile. It's very unlikely that I typed all that in without a single error. That counts as my error. Maybe the rest of it will work. So as long as you add that prototype up at the top and you have this code, it has a chance of working. Going to run it. It creates a file. If we go and look for that file, we can find it, jgt output.txt. It's got our new data in it. No, it doesn't.
I did the press any key to continue, and then it gave me a large negative number.
Yeah,
On exits.
I see that. It's because we didn't close the file before trying to open it again. Let me make sure that that fixes it before I have everybody else do it. Yeah. Alrighty. Go back up into your main, and after your last outfile arrow call, put outfile.close. Now it's got a glitch. It's repeating the last line of data. Yeah, we should be testing for the end of file. What's happening is we're reading in a blank line of data because of this last backslash. But that's enough to illustrate the point. We have written out a file. We use, instead of using cout arrow, we used outfile arrow. And so we were able to write to the OF stream. Just as easy as writing to cout is. I say just as easy. We had to do some prep work though. We had to call outfile.open. We had to check to make sure the file existed. But once we had done that, then we could write to the output file as easy as writing to the screen. And then we call outfile.close. Because if we don't close the file, nothing can go back in and open it. And we get that weird error we saw where we were reading in large negative numbers. Then reading in a file is almost as easy as reading in from CIN. It's the same way. You use the IF stream data type. You specify the file name with a .open call. If that file does not exist, you have to print an error message and bail out. Otherwise, you can start reading your data. We need a slight improvement on this code right here so that if it finds a blank line of data at the end, that it does not repeat it, which is what our program does. And then it closes the file. Okay. So that is file I/O. We have an in-class assignment and a take-home, and if we start trying to do the in-class assignment, I don't think we're going to have enough time to do it. Let's go take a look at it, though. Yeah, let's do this on Wednesday, but unfortunately that means that the homework assignment is not going to be assigned until Wednesday, which is going to be kind of tight because we're only going to have exactly 1 week to get it done. So I'm going to try to make the homework assignment as easy as possible. We'll see how much of it that we can do in class. So with that in mind, since it's almost 9:30, why don't we go ahead and upload the work that you've done into Dropbox, okay? Sounds like I said Dropbox, okay. But so take your CPP file and upload it into the Dropbox. We'll consider that today's in-class assignment, what we've done so far. And then we will work on the rest of this one. We'll make a new Dropbox for it. And if you want to look at it on your own before Wednesday, you can do that, in case you really are worried that you won't be able to do the homework. We'll probably finish the assignment in class, is actually my guess. So everybody get it working, even with that little glitch where it repeats the last line of data?
Is it supposed to keep repeating forever?
Yeah.
It's not supposed to repeat forever, is that what it's supposed to do? Let me see it. That's my mistake if it's repeating. It's not gonna run through it like that. You know that it's a project. Is it repeating, is it looping endlessly for everybody?
No, I'm only getting a done message.
All right. If it's working for you and you're happy, then we can call it in a class. Let's figure out why it's not. So it did open the file and it did create it. If we search for TS output, we'll find it. Let's stick a pause after every statement. Oh, we put commas in our data. Which is fine if our program is expecting it, but our program's not expecting it. We haven't really talked about how to extract data when it's separated by commas. We always use spaces to separate our data so far. So the last read is because we had that last slash in it. If we took that out, we probably would get some of the syntax. Alright. So does that make sense? It just wasn't expecting commas in the input, so it's breaking it out. Okay. Got yours going? Got yours saved? Did it work for you? If you want it to work perfectly, take out the very last slash n on your out file. A line that says out file 895 or whatever it was, take out the slash n on that one. Go ahead. And if you've already uploaded it, it's totally cool. Let's take out that slash n. Go ahead and type it. For me now. All of that is because we cannot find a right. So copy that line. else getting weirdness that they need fixed on? Otherwise, we're done for the evening. Commas in it, and mess up. Take out that, all that stuff. And it's just because when you use this arrow, and we're reading into ends, that better be exactly what the data looks like. If you want to make it capable and in more complex data forms, we have to do more programming code for this stuff. So we got.
Yeah.
That looks like the data you're writing up. Okay. Cool. All right. Let's
Just,
just,
you know, that's, I uploaded wrong homework, just like 2 times. I uploaded the, with the week.
Okay.
Instead of 6 or 7.
all right,
Is
okay.
that fine?
Yeah,
Anyway, can you delete that? On you go.
I can delete it. I'll do that. All right. How's it going?
I'm having issue with the grades array.
Okay.
It will run, sorry, I'll let you finish.
Well, let
your
me make sure
first.
that
Yeah,
everybody
sorry.
got this one done, and I'll
Yeah,
come back.
sorry, I
and
didn't cut.
No problem. So, got your 1, 2, 3 working, or is it?
I just get it done.
Have you done the work?
I'm-
Tomorrow? I just realized it was due
They're
tomorrow.
not open in
Yeah,
What's that about? It's
I've
clean,
worked on it over the
solution,
weekend.
The 12th.
yeah, rebuild it.
And I ended up troubleshooting it down, like trying to make sure everything worked. It commented it out after I made sure.
And there we go, now we got something,
But I've got
that's not what we want.
one of the math functions. And so it's
Stop
giving
it.
me weird numbers.
Same. I forgot that. I don't have on this last one. These are my desktop, but back here, so
Yeah.
just in the picture of it. What did I do wrong? I'm pretty sure it's something like, as simple as, oh, you just put it in the variable and wrong.
Okay. Problem is that this is trying to read into integers, and so this is the only part of the data that is actually valid. This line is not valid. So I think I said comment that out or delete it, but I went through it too fast, and so not everybody got it done.
All assignments, I convert to my time to make sure I can still remember how to do them. Cause I took it as C++ when I a while ago. So this is it's been like that before. Different back, so I don't put it in. So then use like different times files, like, are you sure it's in there? Unless you encrypted your computer, and then maybe by accident,
And there we go.
computer likes to hide your files, cause it's
If we want to make our output a little bit prettier,
my first programming is encrypted.
the commas between our stuff.
And I like to hack some, so I can get rid of some kids and then I can go back and do it. And then I can do it. I have fun. I like computers. It's why I have to school system.
I don't know why
I was
those-
going to do
those
my
stuff.
card, he's like, Drew, you have to do it. And I did it, and he was like, I might need to change things, cause you have to do that. I was like, I can change my grades, and then he was like, I can't do that. Yeah, I can, I'm clear now.
Your program is being very odd. We're making changes to it, and it's not catching it unless we rebuild the project. That's not normal
Been
behavior.
getting old.
Okay.
Okay, there we go. Cool. I don't know why we're having to do that clean build. I apologize for not notifying you. All right, let's take a look.
Okay.
So, these syntax errors. It
Yes.
builds.
And as you can tell, I tried to work every loop, make sure each loop is firing and then comment out the C
Yeah.
code of it.
All right, let's take a
But
look.
I've got a math issue with it.
Joe. There you go. John. Jack. Stan. Does it stop at a certain point? I forget how many names we
There's
told it
10.
to. Okay,
Yesterday, I actually changed it to 3 to
yeah,
try
for
and
testing.
speed this up. You asked for it.
Right.
Fortunately, here's 10. It adds up my grades. Then it displays the grades, adds up my grades.
Okay, so that part's right. Then what is it doing here?
I think this is the addition of the grades.
Okay, we're gonna get totally as fancy as all get out here. And we're gonna say enter name x plus 1 out of this. This is totally just. Yeah, if it's still open, it's not gonna build, is it? Okay. Thinks it did. Let's see. Enter name one out, yeah, okay. And so on, okay. And yeah, I'm gonna grade, change this stuff. So, this is get names and scores from user. Display the table, names and grades. We've got a double loop coming here now. That's the problem, is we really only have one set of data. We have a single array of grades, so we can't use a nested loop for this.
Oh,
So I'm thinking that we probably would just
that's what I did to it.
take that out
Okay.
almost
well,
completely. I can't prove that that's gonna work, but let's give it, let's see what that does. Total divided by 1. We should go into debugging mode and figure it out that way, but. What a weird total. We see it inside the loop because we see it do 20, 50, and 51. So we know total is working. And by the time we get down here, total is not working. Okay, it's getting inexplicable enough that we're going to go into the debugger to figure it out. So I'm going to set a breakpoint there. I'm going to run the debugger. Joe has a score of 10, Sam has a score of 20, and Fred has a score of 11. Now we're at that line. Step over. Total is now equal to 0, 0, 0, 0, 0. Total is plus equal to grades. Text. Total is now 10. Total is equal to plus grades text, 30. So it's added 10 and 20 to get 30. Total is now 41. That's cool. We added 20 and 10 and 11. Now something's going on. We need to make this less than rather than less than equal to.
Okay.
Because if we have an array that's got 3 slots in it, then we only want to hit elements 0, 1, and 2. So you always set your loop to start at 0 and then go up to and not including the maximum. And that will fix that.
I know. Seriously, that's what I did wrong. I played with that, so I mean, did that
Yeah, yeah.
less than equals, I can't believe I just didn't leave it as less than for one of my tips, because I really didn't put everything I could there.
Yeah,
I still got a crazy number.
but that's okay. It hasn't started running yet.
Oh, okay, okay.
I'm just gonna run it again. I'm not gonna step through it line by line. And there we go. So that's really what the problem was. The other problem is that we were repeating this multiple times.
Okay.
And we don't have any sort of two-dimensional tabular worth of table. We just have a line of scores. So we only needed a single loop, not a loop within a loop, if that makes sense.
Okay. Sort of does.
Well, we could put this back in
I
there.
accidentally looped it
We could put this,
excessively.
yeah, we could put that back in there and you'll see what it's gonna do. I don't know why that doesn't work. Tell you what, let's put that in there. Let's take away our little breakpoint. So Fred made a 10, Bob made a 20, Sam made an 11. So Fred 10, Bob 20, Sam made 11, and then it calculates the average one time, then it calculates the average a second time, then it calculates the average a third time. Why is it doing that? It's just repeating the same thing over and over
So essentially.
because of
delete
that for loop here.
That line.
Right, so we don't need that line. Delete me there, and delete the final
And so,
there, yeah.
okay.
But do you see why we had to change it to just less than? Because if months is equal to 3, then you can only access elements 0, 1, and 2. Those are your 3 elements.
Yes.
Yep, classic mistake, that's called a one-off error. It's so classic that it's got a name. because so many people have made it. I don't feel bad about that.
Okay, I've already uploaded this once, I'm gonna upload it again.
Oh, sure,
I'll try to
absolutely.
put a comment, but
Yeah, just say
final version.
new improved version. Yeah,
Alright. Thank you again for
sure
that.
thing.